We didn't intend Living Energy Farm to be a technology development center in the beginning, but we have become that. We've had to figure out a lot of things on our own. You can't go to a big box store and buy all the tools that we need. And I learned a while ago about some ideas about how to run power tools directly off of solar panels. And of course, my to-do list is really quite long, and only got to it in the last week of doing experiments, and it worked out amazingly well. So at the end of the presentation, we're going to have a minor diversion and show you how to run old-fashioned power, circular saws, drills, anything, any of those home power tools. We'll show you how to run them straight off the solar panels. But let's start talking about batteries. So when we talked about the high voltage DC last week, the daylight drive system that we use, we put a warning in there that high voltage DC is more lethal or more dangerous potentially than high voltage AC electricity. You don't want to mess around with it. In building code, at least in this part of the world, 48 volts is the difference between high voltage and low voltage. Anything above 48 is considered dangerous. Anything below 48 is considered not so dangerous, although I actually know a person who was killed by a 48 volt wire, but that's quite unusual. Certainly when you're dealing with battery voltages in the 12 to 24 volt range, there's no particular danger of electrocution or serious shock, but batteries have the capacity to generate tremendous amperage. And amperage is what heats wires up. So while batteries are not going to electrocute you unless you put a whole lot of them in series and get a high voltage, they can melt wires very quickly. They can make a lot of sparks. They can burn your house down if they're not set up properly. So if you don't have any experience with this, you don't know what you're doing, then please, you're taking your own risk. I strongly recommend with any battery set, at the very least, put a fuse on it. What is even better than a fuse is a DC breaker system. This picture I have on my screen is a set of DC breakers from, I think they're from Midnight Solar if I remember correctly, but a lot of the solar companies have DC breakers, and they're not the same as AC breakers. They're going to be more sensitive and more accurate than a simple fuse, but just beware, you can't be hooking up small wires to batteries without some fusing. The fusing of the breakers needs to match the size of the wiring, and somebody who knows what they're doing needs to help you figure that out if you don't understand it yourself, so you don't get a bunch of sparks and burn your house down. All right, so let's go through and talk about standard off-grid design. What I have up on the screen now is a worksheet from Northern Arizona Wind and Sun. They're a good company out in Arizona, surprisingly. We've ordered equipment from them. They have good information. Off-grid solar has become an extremely rare thing. A lot of people are doing grid tie now, specifically because of bad batteries. That's the biggest reason. But we're going to walk through kind of the design process and see how it is people get led down a rabbit hole instead of making intelligent design decisions. So this is a simple list of a bunch of appliances you might have in your house. I just pulled this off their website. So if you were trying to design an off-grid system, they would refer you to this worksheet. You're supposed to go on this worksheet and decide, well, this is what I got to have. Well, there's a well pump. I got to have that. Well, I got to have my coffee maker, but maybe I can give up the toaster, whatever. Now, this is all by watts. Watts are fairly easily converted into amps, and you add a time component under that to get amp hours. Those are all simple mathematical equations. So you look at this timesheet, you check off all the things you feel like you got to have. This is also from Northern Arizona Wind and Sun. So from that previous sheet, you write down your appliance, how many of those you have, and the wattage. You fill out this whole sheet, and that gives you your total power demand. Then you have an idea of how big your system's supposed to be. In most cases, the system turns out to be way bigger than you thought. So you go back and say, hey, what's going on? And they'll tell you, well, you got to trim it down. You know, maybe you can get rid of that coffee maker, get rid of the toaster or something. Otherwise, you're going to have a really big, expensive system. So you try to trim it down some. Most systems end up with 1,000 amp hours in a ordinary. That's a fairly modest system. A lot of systems end up with bigger numbers than that. So then they sell a lot of kits. Northern Arizona sells kits. A lot of other companies sell kits as well. These are the kits from Northern Arizona Wind and Sun. Now these are simply the electrical, the PV panels, charge controllers, inverters, that side of the kit. These kit prices do not include the batteries, which is a big expense, or the solar panel that fits on your roof, because the rack that goes on the roof has to be customized or has to match the roof, you know, the pitch of your roof or whatever. And so the solar rack itself is not really expensive, but the batteries are quite expensive.